Okay, today we're talking about standard deviation, and most all of this material will be new, so be sure and write it all down. Okay, standard deviation. How far something deviates from the mean. Standard deviation in a list, a frequency list. So, here's my first list. Just random. And the first thing they will ask a lot of time is, what is the range? You've had that word, range. The range of these numbers, the big number minus the little number, these numbers range by 8. Then, the next, x bar. What did x bar mean? Last time, x bar. It meant the sum of the x's divided by the number in the sample. Sum of the x's, 2 plus 3 plus 3 plus 8 plus 10 plus 10 equals 5, 6, and 8, 16, 26, 36. 36 divided by the number 1, 2, 3, 4, 5, 6. 6 is 6. The mean is 6. Then we're starting looking for how far they vary. So let's first start by finding the number minus the mean. First number minus 6 equals -4. Second number minus 6 equals -3. Third number the same. Fourth number minus 6. Fifth number minus 6. Last number minus 6. And if you add these up, 4, 8, 10. 10. 10 negative, 10 positive, comes out 0. Always come out 0. The next they're going to have you do a lot of is the sum of x minus x squared. And they will refer to that sum of the squares. The sum of these numbers squared. -4 squared. -4 times -4. -3 squared. -3 times -3. The next one's the same. -2. Nope, +2. +2 squared, 4. And then 4 squared. 4 squared. And then adding up those numbers, yes, you might need a calculator. We can use decimals. Okay, so then they'll take this and do sample variance. And sometimes they'll just use the letter S squared to stand for the sample. S sample variance is the sum of x minus x bar squared, this that we found, divided by the number in the sample minus 1. So we already know that this sum is 70. And since there were 6 numbers, 1, 2, 3, 4, 5, 6, 6 minus 1 is 5. 70 divided by 5 is 14. Then sometimes they want the sample standard deviation. And this symbol they will use for it is S. So what's the difference of S squared and S? The opposite of squaring is square root. Sum x minus x bar squared over n minus 1, or the square root of what we already had, 14, which is about 3.74. Sometimes instead of just a sample, they will want the population mean. And they use the symbol mu equals sum sigma x over capital N, the whole number in the population. Population variance is that symbol and equals the sum of x minus mean, mu squared, over the whole population, and population standard deviation, or omega. Opposite of this is square root x minus mu squared over n. And in our case, we had 70 divided by, but instead of this time at 5 it would be 6, and then take the square root, and you will eventually get to about 3.43. We will also, sometimes they'll ask for the coefficient of variation. Coefficient of variation equals S over X times 100%. So we had X, our S on the first one was 3.74 over, I missed, X bar. X bar was 6, and it times 100% comes out 62, or instead of X bar, mean for the population times 100% equals, and the second number we got was 3.43 divided, it's still the same mean, times 100% comes out 57. And basically it's showing the percent where it varies, deviates from the mean. And one other thing they'll have you calculate. This person, I don't know how to pronounce his name properly, Chebyshev's theorem, and it is 1 minus 1 over, this k is how far it's deviating from the mean, how many units. So we'll just do a random 2 in case it was 2 units away. And 1 minus 1, 2 squared is 4. 1 minus a fourth is 3/4. That means that 75% of the data is within 2 units from the mean. Another way they write this, most of the data falls within the mean minus this k s standard deviation and the mean plus k standard deviation, or in generic population terms, 1 minus k and mean plus k standard deviation. Standard deviation for a list, standard deviation for the whole population. That's a lot to look over. You might need to stop this video at increments and make sure you get everything written down to do this homework. Call me, write me an email. I'll be glad to help.